This is lesson 9.2 in pre-algebra, solutions to linear equations in two variables. Sounds pretty confusing, but we'll get going here, and I think you'll find out it's not too bad. Now, in the last lesson, we wrote our x and y values when we graphed them as something like 3, 2. And then when we had our graph, we could put those points on the graph by going over 3 and then up 2 and show it right there. This right here, when we put our answer, our x and y, together in that sort of format, it's called an ordered pair. The first point is the x coordinate, and the second point is the y coordinate. Alright, so what we're going to do here is show the relationship between equations and our graphs here. Alright, so just like my name is Gary Leiter, that's my written name, and here's a picture of me. I've got a goatee and a mustache and not much hair and probably some big ears. Okay, and there's a picture of me. So there's my name, there's my picture. When we have an equation, 3x equals 6, that's the name, and I can draw a picture of that equation on my graph right here. So really, when we graph something, all it is a picture of the equation. And that's what we're going to be doing in this lesson. I'm going to be giving you some equations, and you're going to be drawing a picture of that equation. And what we're going to start out with is every picture that we draw of an equation in this section will be a straight line. It's just where that straight line will be. Some pictures of a straight line will be that way. Some pictures will be this way, some will be that way. Some are just all over the place. It's just where does that straight line exist on the xy axis? Well, it depends on what the equation is. Just like what your picture looks like depends on who you're drawing it of. So just kind of a real simple idea of getting started and how these graphs relate to the equations that we're going to be doing. So let's look at an equation, and it's 2x plus y equals 3. Okay, so in order to make this a true statement, because of the equal sign, we have to find some number to put in here for x and some number to put in here for y that will make that a true statement. So for example, let's say that we used 5 for x and negative 7 for y. Let's see if that coordinate, or I'm sorry, that ordered pair is going to work in that equation. So let's substitute 5 in for x, and let's substitute negative 7 in for y. 2 times 5 is 10, plus negative 7 equals 3. 10 plus negative 7. Signs are different. We take the difference between the two, put the sign of the largest number on there, and we get 3 equals 3. That is a true statement. So this is a solution to the problem. So that means if we took a graph here, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, okay. So my graphs are pretty lame here. But if we graph this, we go over 5, 1, 2, 3, 4, 5, and up, or I'm sorry, down 7. 2, 3, 4, 5, 6. We're going to need another one. And down 7. So that point is one of the possible solutions to our equation. So I've got that point there. Alright, so let's leave that point there. And let's say that we try another number, or another ordered pair of numbers here. And OCD, I've got to make sure everything's erased. Let's try 0, 3. Let's see if 0 in for x and 3 in for y works. 2 times 0 plus 3 equals 3. Well, 2 times 0 is 0, so 3 equals 3. So that works. So this is that's a solution. So let's graph that. We go left to right 0, and then we go up 3. 1, 2, 3, and we have a point there. Now what I can do is if I connect these points with a straight line, kind of a straight line, that means that this drawing that I have here in pink is a picture of this equation. And also what it means, and this is where it gets a little bit complicated, but maybe not, maybe it's just me, is every single point on this line, no matter where it is, will make this a true statement. I can take any one of these points, and remember the name of a point is always labeled with a number here, an X number, and a Y number. That's how you name the point. Every single point, if I have the right number there, so this one is approximately over 3 down, maybe 3.5, something like that, in order to get down to here. Every single point that I have, if I take the X coordinate and the Y coordinate and put it in for here and here, it will make this a true statement. It will identify this equation by making that a true statement, any of these points. So that means there's an infinite number of solutions here, because this line goes on and on and on forever and ever, both directions. That means there's an infinite number of X's and Y's that will make this a true statement. So this here is a picture of that equation, and that's what a graph does. So let's look at example 1. It gives me an equation, 2x plus 3y equals 6. And it says complete the following ordered pairs so that they will be solutions to the equation. So it gives me a 0, but no y. It gives me an x, but no y. It gives me a y, but no x. And it gives me, again, an x, but no y. What they're interested in having you do in this example is find out what these numbers are. So let's do that. I'm going to put my 0 right here in for my x. 2 times 0 is 0, so 3y equals 6. Divide by 3, divide by 3, y equals 2. So I'm going to put a 2 up there. Then it's given me the y value but no x value. So I'm going to put 2x plus 3. It gives me a y value of 1. 2x plus 3 times 1 is 3 equals 6. I'm going to subtract 3 from both sides. 2x equals 3. And I'm going to divide by 2. And my x equals 3/2. So the number that goes here, and it can be a fraction, doesn't have to be a whole number. Alright, now we're going to look at the last one. And the last one gives me an x, so I'm going to put a 3 in here for x, plus 3 times y equals 6. 6 plus 3y equals 6. Subtract 6, subtract 6. I have 3y equals 0. Divide by 3, divide by 3. Anytime you have a 0 in the numerator, no matter what, your answer is 0. So I'm going to put a 0 right there. So what this did was said, alright, given one of the values, either the x value or in this one the y value, plug those numbers in the equation for x or y, and then find the other one and put there. So these are dependent. This answer here is dependent on what the x value is. If the x value were something else, our y value would be something else. But because it's 0, whenever x is 0, y is going to be 2. Whenever y is 1, x we found out is going to be 3/2. We could also say the other way. Whenever x is 3/2, my y value is going to be 1. Whenever my x is 3, my y value is going to be 0. They're dependent on each other. So let's jump to example 3. Example 2 is pretty much the same thing. and we have y equals 2x minus 1. And they give us a little table here, and they tell us x is 0, and they put a 5 there. And we're not going to do all these, we'll just do a couple. So it's pretty much the same thing as example 1, where I gave them to you in ordered pair fashion like this. Only this way they're doing it in a table for you to just get familiar with that, but it's the same thing. They're saying, okay, if x is 0, what is my y value? There's nothing there, so we're going to fill in that blank. So y is going to be equal 2 times, we're going to put the 0 in it for x, minus 1. So y equals 0 minus 1, which is negative 1. So I'm going to put a negative 1 right here. So this is just saying when x is 0, y is negative 1. Let's go down here to this one. We've got the same formula, but they're saying that our y value is 7, and that equals 2 times x. We don't know what x is. And we'll add 1 to both sides. So that ends up being 8 equals 2x, because those will be 0. Divide by 2, divide by 2, cross 8 over 2 is 4, so x equals 4. So we're going to put that right there. So it says whenever y is 7, x is 4, or whenever x is 4, y is going to be 7. So you just do those tables there for each one of those, and when you're given one, you find out what the other one is. Now notice example 4. It gives us a bunch of ordered pairs, 2, 3, 1, 5, and negative 2, negative 4. And the question is, if we have an equation, y equals 3x plus 2, the question is, which one of these three actually work to make that a true statement? Could be all three of them, could be two of them, could be one of them, could be none of them. So what we have to do is try each one. So we're going to do the 2, 3 first. So we're going to put the 3 in for the y and the 2 in for the x, because that's the position that they're in up there. Alright, so we'll see if this works. 6 plus 2, 3 equals 8. That is not a true statement, so that one doesn't work. Let's try this next one. It has 1 and 5. So it has 5 in for y and 1 in for x. And 3 times 1 is 3, plus 2 is 5. 5 equals 5. So that is a true statement. So that one works. And then the last one, y equals, let me rewrite that, 3x plus 2. We're going to try this one here. So negative 4 in for y and negative 2 in for x. Negative 4 equals negative 6 plus 2. Signs are different. Take the difference between the two, put the sign of the largest on there, and that is also a true statement, so that one works as well. So these two answers, or these two pairs, ordered pairs, are answers to this one right there. But you have to try all three of them to find out which one works and which one doesn't. And so when you look at the problem set and you get down to 21 through 30, they're going to give you an equation and they're going to ask you what makes it correct. Alright, so I want to jump down to the problem set rather than make a whole nother video of the problems, because most of them are going to be fairly straightforward. But when you get one like number 29, where they give you x is equal to 3, and they give you 3, 0 as an option, 3, negative 3 as an option, and 5, 3 is an option. Alright, and what they're asking you to do here is to plug in plug in this number for x and this number for y. Well, notice there isn't a y. If there isn't a y, what must the y be? The y must be 0. And which one of these has y as a 0? This one right here, so this is the only one that works. because I can put a 3 in for x. Is 3 equal to 3? Yes. This one I can put a 3 in for x, but I've got a negative 3 here for a y, and a y doesn't exist, so this cannot happen, and this cannot happen. And if you look at number 30, it's the same way. It says y equals negative 4. Well, there's only one of them that's going to work. I don't have an x value there, so my x is 0. So when you look at these, you'll notice that the coordinate 0, negative 4 is the only one that will work because there isn't an x. It just says y equals negative 4. So I know that one there is the only one that's going to work. So when you end up with situations like this, it can be a little bit confusing. So hopefully that'll help straighten that out. All right, so that's it for problems or lecture 9.2.